This video is about the graphs of distance over time, velocity over time, and acceleration over time. And there will be a few questions at the end where we do word problems, but I'm going to start with the graphs. So here's the free fall motion that we already looked at previous questions that we were solving earlier in different video. So this is video 4 in kinematics, but in video 3 we solve a lot of free fall videos, and you have the link in the description if you haven't watched that one yet. So let's look at this one. So in the free fall we have acceleration due to gravity g, which is 10 meters per second squared, and I'm going to choose the downward motion positive, so I don't have to worry about the negative velocity. So in 1 second, after an object is being fallen down for 1 second, so if this is 1 second, the object has 10 meters per second velocity. In 2 seconds, so if this is 2 seconds, 20 meters per second velocity. In 3 seconds, the velocity is going to be 30 meters per second. And in 4 seconds, 40 meters per second, and so on. So if I look at this problem, I see my velocity is changing every second. It accelerates, so acceleration is 10 meters per second squared. I'm going to look at the distance traveled. So if this was 0 meters per second, what distance did the object travel over the first second? The distance formula is average velocity times the time. And in this case, you have 0 meters per second, and then in 1 second you have 10 meters per second. So the average is 5, and it took 1 second that we're looking at. So the distance traveled is 5 meters. So I see in 1 second the velocity is going to be 10 meters per second, and the distance traveled is 5 meters. Then in 2 seconds, I'm going to look at this total distance traveled right here. Average velocity between 20 and 0 is 10, so the distance traveled here is average velocity is 10, and the time is 2 seconds. So what I see is in 2 seconds the velocity is 20 meters per second, and the distance traveled is 20 meters. Now I'm going to look at 3 seconds. And in 3 seconds, the distance is average velocity. So you're looking at 0 meters per second and 30 meters per second. The average is 15. And the time took to fall that we're looking at is 3 seconds. So that gives me 45 meters traveled. So in 3 seconds, the velocity is 30 meters per second, and the distance traveled is 45 meters. And I can continue for every single one of them, so I will get the rest of the numbers. Now I'm going to use these numbers to graph my graphs. I did place the negatives in my table, so the graph makes more sense because the object is falling down. So when you drop an object, and it's going to be distance over time. When you drop an object, I'm going to say the position of an object at this moment is 0. And from this on, we're going to start measuring where it goes. So I have position is 0. In 1 second, an object traveled the distance of 5 meters. I'm going to say -5 because it's going down. So -5 meters in 1 second. In 2 seconds, an object traveled the distance of 20 meters. In 3 seconds, an object traveled the distance of 45 meters. So it looks like my graph is going to look like this. Now I'm going to plug in the graph for velocity. So at first I start with the velocity of 0 meters per second. And then in 1 second, it is -10 meters per second. And in 2 seconds, it's -20 meters per second. And in 3 seconds, it's -30 meters per second. And in 4 seconds, -40 meters per second. So it looks like my graph for the velocity is going to look like this. Now I'm going to do the acceleration. For the acceleration, I have at 0 before I dropped the ball, the acceleration would be -10 meters per second. Because in a second, your velocity is -10 meters per second, so the acceleration is -10 meters per second squared. In 2 seconds, it's going to be -10 meters per second squared. Acceleration still the same. So acceleration does not change. It's -10 meters per second squared, no matter where you look at it. So I got the graph for the distance, velocity, and time. And if you notice right here, in 1 second, an object traveled the distance this much. In 2 seconds, the object traveled the distance this much. And in 3 seconds, an object traveled the distance this much. So you know that the velocity is increasing. And here you see that velocity does increase. At first it was 10, and then it was in 1 second, in 2 seconds, 20, and then it was 30, and it was 40. But your acceleration always stays the same. So what I want to show you here is this. If I look at the velocity graph, I want to figure out what the slope of this graph is. So I'm going to look at the graph of the velocity and calculate the slope. The slope is the rise over the run. So if I look at this point and this point, the rise over the run. So I have the rise is 10 and the run is 1. So the slope here is -10. If I look at the next slope, right here, my rise is still 10 and my run is 1, and it is a negative slope. So the slope here is -10. And if I look at the beginning, let's say right here, between these 2 points, my rise is 10 and my run is 1. So I still get a slope of -10. So the velocity graph slope represents acceleration. So this is showing what your acceleration is. And this is how we look at this. My rise, so this is the slope. My rise is the change of the velocity, because this graph is the velocity graph. So my rise is the change of the velocity. And my run is the time. And change of the velocity over the time is actually acceleration. So the slope of the velocity graph is going to be acceleration. And if I look at the slope of the graph that is here in distance formula, or the distance graph, I will see that at first my slope is the tangent line to the graph. So at first my slope was like this, then the slope is like that, then the slope is like this, and then the slope is like this. So it looks like it's a little negative first. This one is a little negative slope. This is a steeper slope, so bigger negative slope. This is even bigger negative slope, and this is even bigger negative slope. So the slope of the distance graph, because the slope is the rise over the run. So if I look at my graph, I'm gonna put the dots back where they were, and 45. So if I have my graph like this, if I took one of the slope, I'm gonna take this one. If I take this slope, so I will have the slope right here, and if I look the rise over the run, this is the change of the distance, and this is the time. So the slope of this graph is going to be the change of the distance over the time, which gives me velocity, because the distance over time is velocity. Here you had the change of the velocity over time, which is acceleration. So the slope of the distance graph represents velocity. The slope of the velocity graph represents acceleration. I took the other graphs away, and I want to look at something else interesting for the velocity graph. So at 1 second, we had velocity of -10, at 2 seconds, -20, at 30, at 3 seconds, -30, and -40. I want to find the area underneath this graph. So if I want to find the area formula says it is 1/2, it's a triangle, it's the base times the height. So the area is 1/2, the base is 4, and the height is 40 meters per second, right? 40. So I get 80. And I want to look at what does this 80 mean? If I look at 4 seconds, the velocity was negative 40 meters per second, and the distance traveled 80. So the area underneath the velocity graph represents the distance traveled. So in other words, I could take initial velocity is 0 meters per second. Final velocity is 40 meters per second. And the distance is average velocity times the time. My average between 0 and 40 is 20. And the time I see 4 seconds. So it still gives you 80 meters. So the area underneath the velocity graph will represent the distance an object traveled. We're going to look at some examples right now. I just wanted to show you an example that you were familiar with, and then we're going to look at some different examples. So here's the first example. I want to calculate the distance an object traveled. I can do the same. I can either calculate the area and see what the distance is, or I can do the initial, the final velocity. I will do the physics way. So I have initial velocity is 0, and final velocity is 8. So the distance traveled for, let's call this area 1, and this area 2. So the distance traveled for area 1 is average velocity, and average between 0 and 8 is 4. And the time it took 4 seconds. So the distance traveled in 1 is 16 meters. And you calculate, if you calculate the area underneath, you have 1/2 the base, 2, times the height, 8, gives you 16. And the area for the distance 2 is easier. It's just base times the height. And that gives us, the base is 6 and the height is 8. So this should be 48 meters. And if I do it the physics way, it's average velocity, and the velocity stays the same, 8 here and 8 here, so average is 8, it doesn't change. And the time is 6 seconds, and 6 times 8 is 48. So the total distance traveled is 64 meters, right? 64 meters if I add 16 and 48. For this question, again, they give you velocity over time and they ask you to find the distance. And again, you can pause it, try to find it yourself, and then I'll give you the answer. So I'm gonna pause it myself, do the calculations, and you pause it, and then at the end I will show you the results. So we have the distance for the first one is average velocity times the time, gives me 18 meters because the velocity is 6 initial, the velocity is 6 final, average is 6 times the time, which is 3 seconds, gives me 18 meters. The second distance is, it started with 6 meters per second, it ended up with 0 meters per second, average is 3 meters per second, and the time is between 3 and 4 seconds, gives me 12 meters. And the total distance traveled 30 meters. And I hope you got the same answer with your calculations. So here is one more example. Again, pause it and do your calculations, and then we're going to talk about the results. So let's call this one distance traveled 1, this one distance 2, and this one distance 3. And don't worry that it is below the X line or timeline. Just do your calculations, and then I'm going to talk about what's going to be over these numbers. Pause it and try it. So I did my calculations for the first, second, and the third area, average velocity times the time, and I got 12, 8, and negative 2 meters because the initial velocity was 0, and then it was negative 2, so the average velocity was negative 1 times 2 seconds gives me negative 2 meters. So the total distance traveled is 22 meters. But because one of them is traveled in the opposite direction, so you see the velocity was positive, and then in this area right here, the velocity is negative. So you have positive velocity, and all of a sudden you have a negative velocity. So it went to the 0 velocity, because it's a velocity graph, right? It went to the 0 velocity, and then it started traveling in the opposite direction. So the total distance traveled is 22 meters, but the displacement is 18 meters. Because an object traveled 20 meters this way, an object traveled 20 meters this way, so 20 meters this way, and then an object went back 2 meters. An object went back 2 meters. So the displacement is 18 meters. Here's another example, and I want you to try to figure out there's 5 areas that I divided it into, and I want you to try to figure out the distance and the displacement traveled by this object. And again, pause it, do your calculations. I'm going to do my calculations, and I'm going to go over them quickly after you're done and I'm done. And I want to emphasize that each division on x, so I have 1, 2, 3, 4, 5. So each is 2. And each division on x-axis, on t, 1, 2, 3, 4, 5 is 1. So be careful when you plug in your numbers. So here are my calculations. You can pause it and see how I did my calculations. I used the same formula for every single one of them, average velocity times the time. And so I did the average velocity times the time on one, average velocity times the time on the second interval, and so on. And then I calculated the distance. The total distance is the sum of all the numbers, which is 204, but the displacement is 84. So it looks like at first an object traveled in the opposite direction, maybe negative direction, 60 meters, negative 48 and negative 12. And then an object traveled in the positive direction, 144 meters. So the total displacement is 84 meters. Let's look at these graphs of distance over time and try to figure out what the velocity over time the graph would look like. I know the distance over time graph represents, the slope of the distance over time graph represents velocity. So if I look at my distance over time graph, my rise is 7 and my run is 7. So I know that the rise over the run of this graph is the velocity. So the velocity of this graph is 1 because the slope of that graph is 1. Then for the next part, for the second graph, I have initial position is 0 and the next in 2 seconds I have 6 meters because this is the distance, right? And this is the time. So it travels 6 meters in 2 seconds. And it travels each second 3 meters. 3 meters per second, another 3 meters second. So the velocity here is 3 meters per second. For the first 2 seconds, the velocity is 3 meters per second because the slope of the graph, the rise over the run, is 3. And then it stays at 6 meter mark for 5 seconds. And when it stays at 6 meter mark and not moving anywhere, the velocity is 0. So we do not know how we got from one position to another, but it went from going at 3 meters per second to instantaneous 0 meters per second. Then let's look at the next graph. For the next graph, I see that an object started at 6 meters away from the origin and then ended up at 2 meters away from the origin. So it went from 6 meters away from the origin to 2 meters away from the origin in 2 seconds. So the rise over the run gives me the rise is 4. The rise is 4 and the run is 2. And the slope is negative. So that is negative 2 meters per second for the first 2 seconds. And then an object went from 2 meters to 4 meters in 2 seconds. And if I look again at this graph, the rise over the run is 2 seconds and the rise is 2 meters per second. So the slope is 1 and it's a positive 1. So then the velocity becomes 1 for the next 2 seconds. And then after that, an object stays at 4 meter mark without moving anywhere. So at 4 seconds, it's at 4 meters. At 5 seconds, it's still at 4 meters. At 6 seconds, it's still at 4 meters. And then the velocity becomes 0 for the rest of the time for this graph. And finally, the last graph, we see that an object started 5 meters away from the origin. So the object is at 5 meters away from the origin at 0 time. And in 4 seconds, an object ended up at 7 meters away from the origin. So in in 4 seconds, an object traveled 2 meters. And if you look at the slope right here, it traveled 2 in 4 seconds. So the slope of the graph is 0.5, the rise over the run, 2 over 4 gives me 0.5. So the velocity for the first 4 seconds is 0.5 meters per second, and it's positive because the slope is positive. And for the next part, an object went from 7 meters to 1 meter. So it went the distance of 6 meters in 2 seconds. So 6 meters in 2 seconds, the velocity is negative 3 meters per second. So the next one is negative 3 meters per second for 2 seconds. And then the last part, an object was between at 1 meter mark between 6 and 7 seconds. Between 6 and 7 seconds, an object is staying at 1 meter mark, so there is no velocity, the object is not moving. And these are the answers for this type of questions, the one that we just answered. For these graphs, I have to figure out what the distance looks like given the velocity graph. So for the first part, I see the velocity is negative 1 meter per second. That means an object moves 1 meter each second in the negative direction. So 1 meter each second. So I know if it started at 7, in 1 second it's going to end up at 6, in another second it's going to be at 5, in another second at 4. So the velocity of this graph is negative 1. So my velocity matches the graph of the velocity. So the distance graph is going to be having the velocity of a negative 1. For the next graph, I see that the velocity at first 0 and the object started at 1 meter. So the object did not move for 2 seconds. For 2 seconds, an object had the velocity 0. And then an object had the velocity of 3 meters per second, because this all is the graph of the velocity. So it has 3 meters per second for 2 seconds between 2 and 4. So between 2 and 4, my graph needs to have 2 meters per second. So it has to move 2 meters each second. So here is going to be my graph. It rises 2 meters. It rises 2 meters each second. So 1 second, 2 seconds. 1 second, 2 seconds. And then all of a sudden, again, the velocity of the graph is 0. So it's going to stay at 5 meters and not move anywhere. For the next graph, I see that it starts at 1 meter and the velocity is 2 meters per second. So it moves 2 meters each second. So it will rise 2 meters this second, 2 meters next second, and 2 meters third second. So for 3 seconds, an object rose 2 meters each second. And then the velocity is 0. So if velocity is 0 for 1 second, that means an object stayed at 7 meter mark for 1 second. And then the velocity is negative 2 meters per second. So an object has to drop each or move in the opposite direction. So it moves 2 meters in this second closer to our origin, 2 meters this second, and 2 meters this second, and ends up in the same position where it was. And for the next graph, I see I'm starting at 5 meter mark and I'm moving at negative 1 meter per second for 4 seconds. So I need to move 1 meter down each second, 1 meter in the negative direction. So my velocity is negative, my slope needs to be negative. So 1 meter this second. In another second, I have 3 meters away from the origin. In another second, I'm 2 meters away from the origin. So 2 meters away from the origin. In another second, I am 1 meter away from the origin. So at 4 seconds, I went to this position. And then all of a sudden, the velocity jumps to 4 meters per second. So the slope of the graph needs to be 4. So I'm going to rise 4 meters in 1 second. So from this position, I need to rise 1, 2, 3, 4 meters in 1 second. So the velocity needs to be positive 4 meters in 1 second. And then all of a sudden, the velocity is 0. So an object will reach that position and will not move anywhere because the velocity from now on is 0. So it will stay back at 5 meter mark and the velocity is 0, so the slope of the graph is 0. So here's probably the last problem. I won't be able to cover the word problems in this video, but maybe that's good because we're going to have only the graphs in this video. In the next question we'll have all the word problems. We're not going to be coming back to the graphs. So in this question, I have to convert the distance over time graph into the velocity over time graph. And I see that the distance is staying at 1 meter, so at 1 second it's still 1 meter, at 2 seconds it's still 1 meter, and at 3 seconds it's still 1 meter. So for 3 seconds an object did not move, so that means the velocity of an object is 0. And then I see between 5 seconds and 7 seconds an object moved from 3 meters to 7 meters. So an object moved 4 meters in 2 seconds. So the velocity is 2 meters per second in this case for the last part of this graph. But then in between I have the velocity is changing and I know it's changing because the slope is changing. At first it's this much, and then it's this much, and then it's that much. So the velocity is changing, and I'm just gonna do this part. I'm just gonna connect it because it went from the graph went from 0 meters per second to 2 meters per second smoothly. So I'm just gonna say, okay, the velocity is changing, and I'm gonna change it like this way. For the next graph, I see parts where my velocity is constant, so the slope is constant, and then the slope is changing, and then the slope is constant. So let me do this maybe in different colors. So the first one I'm gonna do in purple. So the first slope is 1 meter per second because the slope of the graph is 1 meter per second, and the last part is negative 1 meter per second. The last part is negative 1 meter per second, so I have negative 1 meter per second for the last second. And then here my velocity, at one point, at this point the slope of the graph is 0. So at this point the slope of the graph is going to be 0. The velocity of the graph is going to be 0 because the slope of the graph is 0. And then it's dropping to 0 here, and it's rising to negative 1 over there. So what I have to do is to connect these two lines with the graph. So the final solution is going to be like this for my velocity, and at this point my velocity is 0. So this is like a critical point where the graph is the object is changing the direction. The object was moving in the positive direction because the slope is positive anywhere here, and then anywhere here the slope is negative. So the graph had positive velocity, and then the graph has negative velocity. Then for the next part, for the next graph, I have again, this is the velocity I know, and this is the velocity I know. So the second part, the horizontal line, means the velocity is 0. So the slope of that graph is 0. And the slope of this one is 3 over 1, so that is positive 3. And then in between, the slope was dropping, so it went from 3 meters per second to 0. So I'm just going to connect this like that and make that graph. The same I'm going to do for the next graph. I'm going to have negative 2 meters per second here because the slope of the graph is 2. Every 1 second the drop is 2, so that is negative 2 meters per second for this part. Then I have positive 2 meters per second for this part. So from 4 meters per second I have positive 2 meters per second. I do have velocity 0 at 3 seconds because the slope of the graph right here is 0. And then all I have to do is just connect the graphs, and that will give me the final graph for my object. And where the velocity is 0, this is where the object is changing the velocity, because at first this part the velocity is negative, this part the velocity is positive. So velocity negative means the object was moving in one direction. The velocity positive means an object changed the direction and moves in the opposite direction. And thank you for watching this video. The next one is going to be more on word problems, and I will see you then.